So remember when I told you guys you will never have to do the limit definition ever again the long way? I was not lying to you. You don't ever have to do that. So whenever you get a question of a limit definition that looks like example 1 below, I don't expect you guys to compute it. I don't expect you guys to go through and evaluate it and plug in the value of h, so on and so forth. I don't expect you to do that at all. I expect you to take from it what the original function is, and then from there be able to take the derivative, and if you have to, plug in the point. Oh, did you catch the speed up? Nice! Okay, if you want to go watch Catch Up on the Walk. Please catch all these kids. Okay, so I figured it out. It'll be on the recording, but I don't care. Lavender does actually keep flies out. I tested it. Because I was trying to do my my weekly parent video that nobody watches, except for the one person that randomly comments on all my videos. But I put like a force field around me, and then once the lavender like went away because my video was too long, then all the flies came. And I'm like, use lavender.
I have like dildo flies. No.
It has a tendency of getting a little stuffy in general in here. So I tend to not like to close the door.
I just poured this up.
Huh?
I just poured this up.
Oh yeah. This could be like online. What? Oh yeah.
We're famous.
Yeah, no, I
Loud.
know, right? That might be there. No, yeah, I do. I will keep, some of the lecture stuff I will keep up for next year if I do the same lesson. Not always do I do that. Like I recorded all 4 classes last year and live streamed all those, and I went to my YouTube account and I deleted all the live streams one by one. So, depending on the situation, I may or may not leave it up depending on the situation. Depending on whether or not I change the notes. Okay, so limit definition. If I have this f of x, right? Then I would have had the limit as x approaches, or h approaches 0, 2x plus h plus 1 minus 2x plus 1 all over h. So I would have taken my x plus h and I would have plugged it in. And back in the day, what I would have told you guys to do is I would have told you guys to evaluate this. Now we define this as the derivative, as f prime of x. So in theory, what you know now is if I can find the f of x, you know what that derivative is. So what's the derivative of 2x plus 1? 2. So in theory, because I've defined this as the derivative, I could say that this entire limit as h approaches 0 of 2x plus h plus 1 minus 2x plus 1 all over h is equal to 2, and I have not computed anything, which is what some of you guys tried to do with the 2-1. You thought, oh, I wonder if she's going to grade it. Yeah, I did, and that's why I took points off. Because you're like, bibbidi bobbidi boo, the derivative of cosine is negative sine. Question, yes, Maya. Okay. So you can get a little bit of weirdness when you guys do. These are always multiple choice questions. But if you look at something like example 1, and let me also be clear, if I was to be given this limit and I was asked to find out what I needed to do, I would take my first part, and instead of x plus h, I would replace it with x, and I would call that my f of x. Take the derivative, and that's where my limit is equal to that. So if I do the same exact thing with example 1, I take my pi plus h and I replace it with x. So then my f of x is equal to cosine of x. Derivative of cosine is negative sine of x. And then I notice I have a pi there instead of an x. So now what I want is f prime of pi, so negative sine of pi, and f prime of pi is 0. Sine of pi is 0, so this entire limit is 0.
So we ignore that minus cosine.
Yep.
And why? Oh, is that because of derivative and then because it's a number?
Well, and because the definition of the derivative does f of x plus h minus f of x all over h.
So when we do over the h, because it's not over, we also ignore that?
You also ignore that.
Oh, because it's derivative.
It's the definition of the derivative, yes.
Oh.
So essentially all you're doing is you're taking that limit, you're extracting out the f of x, you're then taking the derivative of it, and then you're plugging in the value if you need to.
And we ignore the plus h.
Yes.
So we
Basically, we're all
You ignore all h's, you ignore the last term, you ignore the limit part, and all you're trying to do is extract out what f of x is, so that you can use the shortcut. Question. So this section of material is a hodgepodge of random stuff that I can't just make one section. Because otherwise it would have just been literally one example. So there's 3 different things in this objective, and they're all not connected really to each other. If that makes sense. So what you see, I think in the calendar as I put miscellaneous derivatives as the topic is really because I was like, oh, what have I not taught yet? Oh, all these things, and it's all in one section. So they're not really all connected together, other than the fact that you need to be able to take a derivative. Questions? So another random tidbit of derivatives is L'Hospital's rule. L'Hopital. But it's spelled like La Hospital. And there's a lot of memes that go with La Hospital's rule, let me tell you. So if you're bored tonight, look up La Hospital rule memes and you're gonna get a bunch of them. Yeah, if you're bored and you're a nerd, then go ahead and look them up. They're great actually. I think I used one of them somewhere. Oh, back in the day when I used to use edge elastic tests, I used memes for all the tests. I'll have to show you the meme for that one. Okay, so L'Hospital's rule, so L'Hopital's rule is used in certain situations. When the limit, so with this limit, if I were to plug in 0 in for x, I would either get infinity over 0, 0 over infinity, infinity over infinity, or 0 over 0. And so I use this rule every single time I get one of those 4 things. And all of my other techniques for limits don't work. So I can't factor, I can't multiply by the conjugate, I cannot simplify the complex fraction, and plugging in gives me 0 over 0 or infinity over 0.
This would be like the problem that we hate.
Yeah, well, I mean, I would say this. When I give you guys an actual midterm, meaning I'm going to give you guys a midterm that's going to cover the first 0, 1, 2, and 3 units, all your limit stuff, you're probably going to skip because you're not going to want to do it. The vast majority of you guys are feel probably more comfortable with derivatives than you do with limits. I have BC students who took AB last year that still don't understand limits and got 4 on the AP test. Because it's a disjoint thing. So limits are designed to describe what a derivative is.
Oh, well, the derivatives actually.
Where the derivative is actually doing something. That's what I'm saying. Like when people are like, I don't understand derivatives or I don't understand limits, I'm like, yeah, you're totally fine. You know, you could probably still easily pass the AP test without knowing limits. It's derivatives that's a big issue. I get real comfortable with derivatives because with derivatives, there's an antiderivative.
What?
I'm telling you guys this now because
So we can.
so you can enjoy the time.
No, now we're gonna know what's limited.
Right behind us.
Oh, what?
You didn't realize.
You didn't even realize that he's just limiting. You're like, I hate this. Okay.
Happens going to your head.
Alright, so limits. So in this case, I can't multiply by the conjugate. I cannot simplify the complex fraction because there doesn't exist one. So the only thing I can do is what we call L'Hopital's rule. L'Hopital's rule says to take the derivative of f of x and g of x separately as many times as you need to so that I don't get one of these 4 situations. So, L'Hopital's rule is not quotient rule. Harder for me to spell with all caps. I had to pause for a second. Okay, so limit as x approaches 0. Derivative of the numerator is the derivative of 1 minus cosine is sine of x. Derivative of x squared is 2x. Can I plug in 0? Nope. Try it again. Derivative of sine is cosine. Derivative of 2x is 2. Can I plug in 0? Yes, so cosine of 0 over 2. Cosine of 0 is 1.
Wow.
I will caution you when we take our quiz next week. Pick all the easy ones to do first. Because we're about to get, you know, like some of these are getting a little more complicated. Some of these require effort. Oh, I just realized something. Yeah. Okay. That could be a tomorrow problem. No, I realized something because I taught this yesterday. So I speed taught 214, 215, and 216 in BC yesterday because I've got a group of students who are trying to get ahead. Did you ever do that to yourself? We're trying to get ahead and do the review assignment and stuff early. Right? I'm like, go like, I don't know, binge watch something. Like, but, so I speed taught those 3 lessons and then realized something that, and I just realized it right now, is that when the inverse function thing doesn't exist in the notes. For the derivatives. So they actually can't answer the review. It's okay. I realized that this notes page here was supposed to have something, and it doesn't. It's missing a slide.
Get ahead.
Wait, is your review time review?
Yeah.
When's that? Next week?
Yeah. Yeah, so we do 214. 214 was supposed to have derivatives with inverse functions, but it doesn't. So, I will probably show it to you guys on the day of our review. Tomorrow's going to be a little much. So, see, we have 214, that's today. We'll do 215, 216 tomorrow. Friday will be open work because it is Phoenix full schedule, and then everybody's got a college class, so we're all over the place. Monday is your day of review. Tuesday is your quiz. Wednesday is PSAT for everybody unless you're a senior. Thursday is your quiz corrections, and Friday is your test for this semester. Right on top of my head. Yeah, so PSAT is on Wednesday. And then juniors, so seniors are going to go check in with Maria on the PSAT day because I'm proctoring PSAT. Just so you guys are all aware. Okay. Now, I understand a lot of things. What I understand is some of you guys care an awful lot, and some of you guys care very little. Okay. So, when it comes to this next thing, this other thing that's kind of all disjoint, when it comes to this next thing, what you guys have to understand is there's a reason why derivatives don't exist. There's certain situations where derivatives do not exist. Typically, you can just know that you're going to have an issue where derivatives won't exist. I can give you those specific cases. If you want to know why, the reason why is because the limits themselves, when you do the limit definition of the derivative, they don't actually exist because the slopes of the derivatives aren't the same. It'll make sense when I show you guys an example. But I'm not going to sit there and go through. This is all limit definition stuff. If you actually care, vast majority of you guys do not, and that's totally fine. But in the end, what you need to care about is, and I'm going to scratch out example 3 for a second, because I'm going to do example 2 and 3 together. Where does a derivative not exist? A derivative does not exist where you have an absolute value, possibly, and only a one value of x for the absolute value. And when you have fractional exponents, and only one value of x. Everywhere else is differentiable. Everything that you guys have seen before has always been differentiable. I've never given you a non-differentiable point. Okay, you have not seen that yet. But here, with my absolute value of x, minus 2, whatever my absolute value is set equal to 0, so x is equal to 2, is my non-differentiable point. It is called a corner. And why is it called a corner? Well, if we think about what we normally do when we graph absolute value, right? We take the absolute value back in advanced math. We take the absolute value inside. You set it equal to 0, and that becomes your vertex of your absolute value. But I take 2 and I plug in, and I get 2, 0. So 2, 0 is my vertex. And then my absolute value graph looks something like this. It is a sharp corner at the vertex. That's why it's called the corner. It is not differentiable at x equals 2. But the reason why is because if I look at the slope of the tangent line, going towards 2. On the left side of x equals 2, my slope of my tangent line is negative, and on the right side of 2, the slope of the tangent line is positive. Because there are 2 different values, the derivative doesn't exist in that point. Because the slopes don't match. The slopes have to match every single time. Okay? And that's doing that without doing the limit definition and confusing the heck out of you guys. Okay. Questions? So there's what we call cusps and vertical tangents. So let's be clear, non-differential points. Corners, cusps, discontinuity. If it's not continuous, it's not differential. Okay. So if I had f of x is equal to x plus 1 to the 2/3 power. X plus 1 is equal to 0, so x is equal to negative 1. At x is equal to negative 1, it is not differentiable. We ignore it. So to find it on non-differential point, we take what's to the fractional exponent and we set it equal to 0. Similarly, like the absolute value, we ignore the absolute value. We said what's inside the absolute value equal to 0. And that gives us a
negative 1 is not
correct. Everywhere else it is. What ends up happening is in these 2 situations, there's another situation too. I'll label this up. Differentiable means that I can take the derivative at that value. I'm going to do it to the 1/3, so where you have an even numerator exponent or an odd number numerator exponent. Same thing, x minus 5 is equal to 0, excuse me, x is equal to 5, so at x is equal to 5, it is not differentiable. Correct. Here's what's going to happen. So first of all, in these 2 situations, one of them is a vertical tangent and the other one looks like the McDonald's M. At the base of the McDonald's M, right at that point, it is not differentiable because in theory, there's a vertical. There could be a vertical tangent, or what you could have is one slope is going to a positive infinity and one slope is going to negative. In theory, all you need to know, if you wanted to not care where it came from, is anytime I have a fractional exponent, whatever's inside the parentheses equal to 0 is a non-differentiable point. Okay. What that means is that what's going to happen on your actual test, I'm going to ask you, find the derivative of blah, 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 right? And it'll say like f prime of 5. F prime of 5 for this one. Okay. So you're going to go through and you're going to take the derivative and you're going to plug in 5. And one of the answer choices will be does not exist. If that's where you have to understand that when you take this derivative and you plug in 5, you're going to have a problem. But you would know that. Without me saying this to you, you would know that. Because if I go through and find g prime of x, right? 1/3 x minus 5 to the negative 2/3 times 1 because it changed. Right? Negative 2/3 goes to the denominator. So this g prime of x is 1/3 x minus 5 to the positive 2/3 Calc. When I plug in 5 in there, it doesn't exist. I get 0 in the denominator. So you're automatically going to know. You're going to be like, oh, crap, it doesn't exist. I get 0 in the denominator. absolute value, you're going to look at that, you're like, how am I going to take the derivative of an absolute value? Right? And then you're going to skip it. More likely. Unless you remember that absolute value is where I have non-differential points, so more than likely this is a differential.
Those kids just guessed.
Yeah, yeah.
It's like 50 shot.
Yeah. Questions about this?